Bismillahirrahmanirrahim. Assalamualaikum. Welcome to the Radio Institute. We will continue with our program in the international research class. For this time, we will discuss about the how to apply the OPTIM to make the one research article to be clearly. I mean, with the OPTIM, we can understand about the some model in the one research article. Okay, our discussion today based on the one research article that published in the international journal with the title Determination of Probability Distribution Function for Modeling Path Loss for Wireless Channels Application over Microcellular Environments of Ondo States Southwestern Nigeria. In this research article, we have this data set path loss for the wireless channel, and then we try to modeling this data using the 6 model. According to this research article, there is 6 model that we can use to make the probability modeling for the data set path loss, such as logistic distribution function, gamma distribution function, log normal distribution function, WEIBULL distribution function, normal distribution function, extreme distribution function. The 6 model we can discuss, but for the first time, we must focus for the 4 model only, such as gamma distribution function, log normal distribution function, WEIBULL distribution function, and the normal distribution function. For the logistics and the extreme distribution, we will discuss for the next time. Okay. The 4 model is very familiar with us, like the gamma, WEIBULL, normal, and the log normal distribution function. For WEIBULL and gamma distribution, we have discussed. Okay, we have discussed using the OPTIM to estimate the parameter. And then for the normal and the log normal distribution is a very easy to estimate the parameter. For the normal distribution, we just take the mean and the standard deviation. And then for the log normal, the first step, we must logarithm natural the data. And after that, we take the mean and the standard deviation. So we will try to solve this problem. We will try to comparison the 4 model, and we choose which one is the best using the density plots. Okay, we will open our R software. Okay, we stop share, and then we try to open our R programming or our R software. Okay, for the first time, we will try to call our data. We give name X. X is a read.csv file.choose. Okay, we choose our data, path loss data. Okay, this one, path loss data. Okay, if you want to know what kind of data, we just type the heat X. So for the path loss data, we have the longitude, latitude, elevation, altitude, cluster height, distance, and the path loss. So the 7th column, this is the data that we want to try for the 4 model. So we just call X is the 7th column. X is the 7th column. And then X, this is our data. This is patch loss data. Okay, after we have the data, so we try to estimate the parameter using the OPTIM. Okay, we have the gamma and the WEIBULL. I think it is not important. It is not important again to discuss about the gamma and WEIBULL, how to the estimate using OPTIM, because we have discussed this distribution. This one is for the WEIBULL. Okay, and this one is for the gamma. Okay, and then this one, now this, like I say, for the normal distribution, we just find the mean data and the standard deviation data. For the log normal distribution, for the first step, we must take the logarithm natural of the data. And after that, we take the mean data and the standard deviation data. Okay, this is very easy for the normal and for the log normal distribution. The parameter of the normal distribution, just the mean data and the standard deviation. And the parameter for the log normal distribution, we must take the logarithm natural data, and after that, we can find the value of the mean and standard deviation. After that, we must make the comparison for the four model. Which one is the best? We use the density plot. Then density plot, of course, we must create the histogram data. And then after histogram data, we must make the WEIBULL, the density WEIBULL, and then CT gamma, and then CT normal, and then density log normal. For the density WEIBULL, we must use the XI, not X again. XI, it means the sequence data start from 0 until the 2 multiple maximum data with the start 0.01. Okay, we must give the lot of points for the make the best pictures, the good smooth for the picture of the density function. Okay, let's run our program. We run our program, start from here. Okay, start from here. So we run our program, come to the console. So the whole program can be success. Okay. If we want to know what the parameter for the WEIBULL distribution, we just type the MLEW. This is parameter for the WEIBULL. And the convergent gives the 0 value. It means the OPTIM is success to the estimate the parameter. For the gamma, we just type MLEG. MLEG. Okay, so we success. This is a parameter for the gamma. Okay, and for the parameter normal, we just type the MNL, or we could for the normal MNL. Okay, MNL. This is parameter for the mean of normal, SGL for the standard deviation. Okay, and then for the parameter log normal distribution, we just type the MNLN. Okay, this one, and then for the standard deviation, we start as DLN. Okay, this is parameter. After we are success to find to estimate the parameter for the four model, we run our program to make the comparison using the density plot. Okay, like this one, you run your program here, run. And you can check. Okay, I think it is a nice, very, very nice picture. Very, very nice figure. You can see that the orange one is for the WEIBULL distribution function. The pink one for the gamma. Blue one for the normal. Green one for the log normal. And for the gray is the histogram, the real data. you can see the figure. The Weibull distribution is very close to the histogram. It means the Weibull is the best modeling for the path loss data. I think it is a very, very nice discussion for this time. Okay. Okay. Rado Institutes always try to give the best that we can give to our student. I hope our discussion today can help the student to finish their study and they must have the good research article and then publish in the international journal, of course. Okay, I think that's enough for this today. Enough for our discussion today. Okay, see you again, Rado Yendra and Rado Institute.